Assalamu alaikum. We know the distance between focus and the pole of a lens is referred as focal length. In this video, we'll get the expression for focal length of two lenses in contact. For that, I consider two lenses. Lens 1 and this is lens 2, which are in a contact. As you can see in the diagram, they are in contact. Now, I take this point where these two lenses are in contact as the common pole. We know for a lens, the geometric center is referred as its pole. This is the pole of this lens, and the line which passes through the pole is referred as principal axis. Now suppose a ray hits or incident on this lens. After refraction, it will pass through a point. We call that point as a focus. Sometimes it is also referred as principal focus. The distance between focus and the pole of the lens is referred as focal length. Clear? Now, I draw a line here which passes through this point, which I have referred as pole. This is the pole, the common point. And this line which passes through this one is referred as the principal axis. Okay. Now I name this as lens 1 and this as lens 2. The focal length of this lens 1 is taken as f1 and the focal length of lens 2 is taken as f2. What is so? Now I take one point on the principal axis. I name this one as object O. So this point which I have taken is nothing but a point object. Now a ray of light is passing through this. A ray of light from the point object is meant to fall on the first lens. If I consider the presence of only one lens, then refraction may occur from this, and as a result, it will produce an image here at this point I dash. Here I dash is the virtual image. Now before the formation of I dash, refraction takes place through the second lens and it forms a image somewhere here at point I. Now you remember this image I dash acts as a virtual object for the lens 2. So the distance between O and P is taken as U, which is nothing but object distance, and the distance between pole and the image is taken as V, which is nothing but image distance. Now similarly, we have got one more thing here. That's nothing but the distance between virtual image and the pole. It is taken as V dash. is taken as V dash. Okay, so these are the things we have here. Now I'll go ahead. To get the focal length of these lenses in contact, I'll start with the lens equation. Lens equation. We know lens equation is nothing but 1 by V minus 1 upon U equals to 1 upon F. So lens equation relates focal length, object distance and image distance for a given lens. I take this one as equation number 1. Now I am going to write the lens equation for first lens. Lens equation for lens 1. Okay, what is that? Here, you see, in this case, for first lens, the object distance is taken as U, whereas the image is found to be produced at point I dash. So V is taken as V dash, and focal length here in the place of small f, I'll write it f1. So by substituting these things here in this equation, in equation number 1, I get the lens equation for first lens. Something like this: 1 upon V dash minus 1 upon U equals to 1 upon F1. It is taken as equation number 2. Now I am going to write a lens equation for second lens. Lens equation for lens 2, for the second lens. See, for the second lens, the object distance is nothing but V dash. Now I told you earlier here, I dash acts as virtual object for the second lens. So the distance between pole, common pole, and I dash is nothing but V dash. So it is kept as the object distance. Then V, there is no change in it. It is taken as V only. Then F is chosen as F2. Now by substituting these things in equation number 1, you see what I get? I get this: 1 upon V minus 1 upon V dash. The place of U, I write V dash. 0 to 1 upon F2. This is taken as equation number 3. This is taken as equation number 3. Clear? Now I will add equation 2 and 3. Equation number 2 and equation number 3 are added. On adding these two, what I'll get? I get this: 1 upon V dash minus 1 upon U plus 1 upon V minus 1 upon V dash. This side 1 upon F1 plus 1 upon F2. This is chosen as equation number 3. Clear? This two it cancel as they subtract, and what remains is nothing but this. I'll take the positive values first. 1 by V minus 1 by U equals to 1 upon F1 plus 1 upon F2. This is chosen as equation number 4. Now I am going to compare equation number 1 with equation number 4. On comparing 1 and 4, comparing equation 1 and 4. If we compare these two, what do we get? Now you can see, if you compare these two equations, you may find that the terms present on the left hand side is same. If it is so, the terms on the right hand side should be equal to each other. Okay, so 1 by f is equal to 1 upon f1 plus 1 upon f2. Here, the reciprocal of focal length. Reciprocal of focal length is nothing but power of a given length. 1 by f is nothing but p, power of a given length. So, if 1 by f is p, then 1 by f1 is taken as p1, 1 by f2 is taken as p2. Okay, it goes like that. Here, this equation, I name this as equation number 5. Equation number 5 holds good for any number of lenses. Here, we have taken only 2 lenses, so we have added reciprocal of f1 and f2. If you have 3 lenses, then the equation will be something like this. 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3. If you have n number of lenses kept in contact, then in such case, this equation will go up to 1 upon fn. So this clearly shows that the power of all the lenses get added up when they are placed close to each other. Understand? So, if there are n number of lenses are present, then the power will be plus P1 plus P2 plus P3. It goes up to Pn. We will written in this manner. And a second thing, if you take large number of lenses and place them in contact with each other, then in such case their magnification will get multiplied. Okay, the magnification of the lens, magnification of lenses in contact will be given as the product of the lateral magnification of each lens. Suppose if m is the magnification, the total magnification, then it will be found equal to the product of m1, m2, m3. Now it goes to mn. This clearly shows that when we place lenses in contact, their magnification gets multiplied. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your question in the comment section. Thanks for watching.